Here we go. All right, here we are. So I will switch to, no, I keep it like this. All right, here we are. Oops. Should be fine now. Sorry for the tech. When my voice duplicated, it was the sound from the stream. So at least it means that we are on YouTube as well. And welcome people who already managed to join to our second webinar. And together with me, there are also Matt and Dan from Event Store. So Matt and Dan will be, or at least Matt, promised me to monitor questions this time. So he might answer your questions by typing, and some questions will be marked as to be answered online. So I will take them at the end of the webinar. So you can try raising your hand if you have a question during the webinar, but we'll see how it goes. And I try not to consume 2 hours of your time like last time, a little bit less than that. So what are we going to talk about today? It's about event sourcing CQRS. So last time we discussed event sourcing as such. So I converted, or like I almost converted a non-existent application that had some sort of primitive persistence to traditional state-oriented database to event-sourced application with a small API, and we looked at how it looks in the Event Store in a real infrastructure. So today I'm going to touch a bit upon CQRS and what it is and why we need it and how it relates to event sourcing. So let me try doing this. So we'll be this one. Let's see how the sort of stereotypical application would look like, or how we used to develop things before, or like what is it, how the application looks like if it's not event sourced. Overall, what is three-layered architecture or layered architecture we used to call it. So you've probably seen something like this many times. You have an application that has a domain model in the center. Sometimes it's called business logic, right? And there is some sort of a service layer, and you talk to the API or directly to the UI, and everything goes down to the database. So if we imagine that how command flow, or in general how the flow works, in this sort of application, we will imagine something like this. So we have a call coming to the API, right? An API sends it to the service. Service calls the domain model. The domain model retrieves an aggregate from the persistence layer, which is the database in this case, does some operation and puts it back, and then it all returns back, right? So this is how it usually works. But we only touched upon command handling before in the previous webinar. So let's see what it takes us to execute a request to show something on the screen. Imagine that we have a user, and the user, instead of executing the operation, before executing any operation, you need to know what they're doing. So when you log into, we did this, our sample domain was the booking application. So we were looking, okay, the user clicks the book button, and we send a hotel ID and the customer ID and stuff like that. But of course, before you can book anything, you need to have something on the screen, some sort of a list. So just let me scroll it a little bit. Some sort of a list with the hotels and nice pictures and stuff like that. So before you can choose what to book, you need to look at it. So what would it take in this sort of application for us to retrieve data? So we will call an API asking for data. This will be a query, usually executed like GET requests. So it will go to some sort of service, and the service will do what? So we do have a database full of aggregates, like let's say we have a hotel, what could it be? Hotel catalog aggregate or something like that. And then there are a bunch of documents or records and tables that represent these hotels one by one. So we will ask the domain model, yeah, give me all hotels, right? But people usually don't look for all hotels. They want to book a specific one, like I'm not going to look to all hotels in the world. If I'm going to London, I want to see all the hotels in London in a certain price range. So the query can have many sort of parameters that will tell the service what the information, what kind of information the user seeks and what needs to be returned. So we all remember, or at least some of us who followed the book, the domain-driven design book, and tried to implement something, we start to talk about repositories. So repositories, the idea of repository was pretty simple. If we look at it in theory, the repository is just a representation or collection like a representation of all the business objects that we have in the system. So let's imagine for a bit that we are implementing this sort of stuff in code. So I will switch to my IDE and try to run or create something very. So is it the right one? No, it's not the right one. Okay, so I have this thing that's called despicable, and I would say I want to have a repository. So it will be hotel repository. And imagine that I have some kind of class that's called hotel. And a hotel will be like saying I have an ID. CT. Price. This is a primitive one. Of course, no hotels are represented like this, but still. And then I would say I want to have a hotel repository, and the first method that I implemented that repository would be very similar to the aggregate store that we used before. So I'd say I need to return a hotel, get and then string ID, and there will be something there. And I could also say I want to store the hotel, so I would not use any async. I would say just do that, or usually it's called like update. So, and then now we need to search. So what people usually do, like, okay, I would have a method that returns me a list of hotel, and then let's say get or search hotels by hotels in the city, and then you say string city. But then they say, okay, we need one more method because our API needs now to search this also including price range. And then you start populating stuff like double price from double price to, and then you come up to the need that your customers say, I don't want to see all the hotels, I want to see only the hotels that are available at my travel dates. And you add more and more methods. So people get tired of this, and what they say, okay, I want this, and I'm going to implement something that I can call a sort of hotel specification. That would have something like it will be a builder with city, and you imagine what I'm talking about. So you can add more methods, and somehow it creates a class that will be kind of converted to a query to your persistence. So at the end, you can imagine something like this. So query and cd equals cd or something like that. So when you do stuff like this, in principle, it's not that bad. So you have a way to express your need for querying using your domain model. But sometimes people get overboard, and you probably, many of you seen big discussions about the repository being new singleton, and there are pros and cons and stuff like that. And people mainly complain about stuff like this. A repository of T, where T is an aggregate. And then you imagine that you do this, load. Sorry for typos. And then you say void save T entity. It's not a repository, it's an interface. No smiley faces for repositories. And then what people do is like, I want to do INumberable of T, let's say find, and then they send the specification. Specification of T. And then actually after this is done, the whole hell gets loose, because you can never generalize repositories as such, because repositories have specific persistence. And since your aggregates are stored using a specific persistence mechanism, for example, you store them as Mongo documents, it has certain requirements how documents need to be fetched back. And you get to a problem of reporting models that they actually do not really match the expectations of the domain model. So how you persist your aggregate is not exactly how you want to retrieve information. So another problem is that basically, when people do things like that, they start to, like, forget about Mongo. Maybe that's easy case. What if you have a relation database? You cannot do that without using ORM. You can, but it can become really hard. Because imagine that if you want to save an entity and then you have a relation database behind it, you need to figure out what got updated in order to not to update all the properties or all the rows or columns in that row. And that table, maybe it spreads into 5 different tables because it's an aggregate that contains value objects, it contains entities and stuff like that. So it can be a pretty tricky business. So you really need to know what you're updating. So you need to compare what was there before, what's there now, what I need to do. And you say, oh, I don't want to do that. Let me use Entity Framework. And basically you do this, add Entity Framework, and you create DB context and say it will figure out the dirty session and flash only the updates I want. It actually can work pretty nicely today, because when I was writing my book, I looked at current state of Entity Framework, and it was working decently with value objects, pretty well with aggregates and stuff like that. I can only imagine that how much time it took Gilles Lerman to convince Microsoft people to do it properly. Nevertheless, it's still pretty hard. The query is unpredictable, and you lose control of your persistence because you basically outsource all the work to some sort of framework. But still, it doesn't solve your real issue. And the real issue is that, okay, I do have a hotel aggregate, but what about if I have another one that's called, let's say, reservations or availability. So, and then you can quickly find out, if you ever do any booking business, then you quickly find out that you cannot hold availability and scheduling in the aggregate that belongs to, actually represents the specific like building or accommodation or stuff like that, because the capacity and all the things, the properties, like how many stars they have and how many rooms, is the thing that nearly never changes, and something that represents their capacity or their availability changes all the time, because people book hotels, people cancel their booking, and there's a all different bound context. And let's say we decided to keep availability in different aggregates, keeping it in the same context, and then you say, I have this public string hotel ID. I'm not using value object, but you should, but just bear with me. And you say daytime, date, and you have and available rooms. So by doing that, you say, I have, for every hotel, for each day, I have a number of available rooms. I don't even need to know at the moment which rooms are available. I just know that there are available rooms. You might separate it by room type and stuff like that, but it's a bit more complex. So now you want to have a way to retrieve available hotels. So your API has a demand to say, give me only hotels that are available on that date, and you return it to me with information about the hotel as well. So if we know the, Udi Dahan often gives the Amazon example. So Amazon, if you look at their sort of, their website, I will do it now, and I will show what I'm doing. And for example, I will look for the book. And you can see this is the book. So you can see a bunch of information here that is kind of split into different sections. This is the picture, this is me, here, this is the title and a bunch of stuff like paperback. What? I don't know why it costs $80. I think it's becoming rare. So, and you have some pricing details here, and you have also books you might like and stuff like that, and you have reviews and you have details. Like this product details is something that's fixed, like in stone, it never changes. The list of books that I might like based on my own preferences about the book, about different books in general, what I'm interested in, and also considering what I'm looking at. Pricing comes depending on where I am, probably, and this is actually representing me because it can deliver to my iPad Pro. So this is complex stuff. So say, okay, I have a book aggregate, or I have several of them. For example, one represents the product details, including the picture, and there is apparently a record of me as an author, and I can go to author portal and access my details and edit them, and they store separately from the book because they need to be updated only once. And then when I query the book, my name and my picture from my profile that I edited on author portal will be changed for all my books. Luckily, I only have one. But this stuff is very dynamic, and this stuff is even more dynamic. So one way of doing that is do the service composition. Let's say I have, let me remove this drawings for now. It's quite a lot. And I do the same query, right? But I do not have one domain model, but I have multiple services here. So this is the books, and this is authors, this is recommendations, and so on. And they all have their own domain model, and they all have their own persistence potentially. But maybe, okay, let's say it's the same database. So how does it work? And everyone has here, every single piece of it has their own repository. Here, for example, we have one repository, here another repository, and stuff like that. So what do? You like create a backend for front end, so the API will split requests to different services, and they all go to different databases. But it can be very hard because, for example, to get available hotels, you first need to query the availability, and then return it back, and then based on the information that's returned, you query only the available hotels to retrieve their pictures and stuff like that. And when you get a list of available hotels and do some additional querying, you might need to query the pricing, for example, for those specific dates. So it can be really complicated because what do you need to, the operations you usually execute, not usually, you actually have to execute operations transactionally unless you know aggregate, because that's the rule. The aggregate is a transactional boundary. But it doesn't apply to queries. Queries are much more versatile, so they can go to many different places to fetch data on very advanced conditions, especially when it goes to search. Because you rarely search for a specific aggregate, because as a user, you don't really care what kind of structure or what kind of context you have, even if you have a repository of aggregates or whatever else. So that's why this is a tendency, or there's a saying that DDD and the repositories don't fit the reporting needs, because reporting needs exceed the complexity, or the complexity of reporting becomes unbearable when you do the DD. So therefore, long time ago, Greg Young came with the concept of CQRS. So what is CQRS? CQRS is a relatively simple thing. So for the term itself, let's say it like this, it, so let me add one more thing, one more section. No, not this one. I'm trying to do this. It looks like I'm trying to do something wrong. Yeah. It's basically this command, and then you scroll. Query. Sorry, you will hate me for this. Segregation principle. So what Greg said, okay, the need of the domain model to persist aggregates is drastically different from the need of the application to query data from the variety of services or variety of interfaces that exist in the systems, or all this range of domain models that you might have. Because when you execute a command again, you execute on a single aggregate, it's pretty simple to store and retrieve and aggregate using a repository or whatever else you use. But when it comes to querying, you usually go across one single aggregate. So your repository is basically becoming useless because you cannot retrieve all data at once. So some of you might be familiar with CQRS, and the question is always asked, what is the difference between CQRS and CQRS? So if you look at the code that I have, just one sec, I'll switch the screen. This one, yes. So this is the query, and this is a command. So this is all of CQRS. Something that returns, the method that returns, the function that returns something is called the query, and it should not have any side effects. Basically, it just retrieves information, returns to you, and it cannot have side effects except of stuff that is technical and is not really changing the system. So, for example, you can log. Logging is a side effect, but it's not changing your data. So this is a command. The command doesn't return anything. It can return type of unit if you use functional languages. We can return saving the result. Again, it cannot. Its intention. The intention of every command is to do something. Basically, it must produce a side effect. Otherwise, it needs to return something like I haven't done anything, or it crashes. So this is definitely query. But for the CQRS, it goes on the, not on the method level, it goes on the, we can say it on the interface level, on the API level. So for CQRS, all this is sort of on the command side because you're only loading aggregates and saving them back when you execute a command. And everything that looks like this is a query. And they are completely separated because the idea always was like, how would I persist data for reporting? It really has no real direct relationship with how I persist data for how I persist my aggregates. I'm not interested to retrieve aggregates because I only need partial information for some queries. For example, I just might need a list of countries. I'm not interested in country codes. I'm not interested in the currency. I'm not interested in time zone, although I might have all this information. So very specific, very concise request to retrieve part of the information, but also it can go across many different places. So if I try and maybe succeed this time to draw a bit better, and it should move the screen when I'm moving, but it doesn't do that. So let me try to visualize it. Yeah. So what can happen is that, okay, when you execute a command, I will draw it in different colors. So this is a command. It goes to the domain model. And then it can go to the repository or whatever you use. And the repository talks to the database. And there might be multiplicity of those models and databases, and maybe different tables or whatever in databases, but they all isolated. So this guy is isolated from this guy, and this is how it should be. However, imagine that we have queries. So I will do it in a different color. So this is the query. When you scroll, and the query comes to an API. Let's say like this, we can call it query API. And this query API can just either call a query service or it can just go to this database and compose something and return you the result. It would be the API composition that I touched upon before, but it could be as well that you, for example, have another database over here, and imagine this is called Elasticsearch, and you would never use Elasticsearch to persist your aggregates because it's not designed for that. And instead of querying all these databases, somehow you establish a mechanism that data from multiple databases will come to Elasticsearch, and then what you do, you query Elastic and execute a search query, for example. So I'd say that this was the original idea of CQRS. The basic idea of CQRS was that you have a single database like this, and let's say you have a table or whatever. It was a long time ago, so everyone talking about tables. And you have the command that goes through the domain model and persisted in the table, but you can also have some sort of view, right? And the view is populated from this table or maybe some other table as well. That is a different aggregate. And then the API that needs the query calls the view instead of going through the repository. It can just execute query that goes to multiple of those tables. You don't need a view or whatever else. So I've heard many times that this particular pattern is very useful because then you can use ORM to persist your aggregates in a complex table structure. But then when you do queries, you can just execute a SQL statement and off you go. You're free to do whatever you want in queries because basically queries do not have any side effects. The only problem that I can't foresee that you hit the same database, so if you have disbalance between reads and writes, you don't solve it because your tables will be still the same, and you won't resolve that. So yes, one of the things again that people often solve by doing this kind of stuff with putting data in a parallel database is that there is a how it's called, disbalance between reads and writes. So imagine that we talk about the hotel stuff, right? And let's see how often we execute operations. So imagine we are on booking.com with huge business, and we have users that look at our website and make reservations. So I would say that if we look at command side, we have, like, let's say, okay, we're a very small booking.com, so we have 10 bookings per second. And it goes to this database. So far so good, 20 bookings per second, nobody cares. But people who execute queries, they are like crazy because people want to go on holidays, they're not sure where they want to go and stuff like that. So they execute queries like hell. And number of these queries can like exceed 10,000 per second. And there is a very old pattern that Eric Evans and Martin Fowler were talking about this 15, 20 years ago. Do not use your transactional store for retrieving information. So transactional store and reporting store are two different things. So basically the idea is pretty old. I think it actually was there before. I just heard that Eric and Martin, they wrote a paper about it. So this is the transactional store over here. This is used to execute commands. This is the reporting, no, this one. This is the transactional store, and this is the reporting store. So separating two data into different stores allows you to basically approach and fix performance problem that caused by a read-write disbalance. In companies like the company I worked for, ABUX, when we deal with IoT, it's different, because people who execute queries, they're just like a few tens of thousands of them. But devices that report the data, there are hundreds of thousands of them. And they report, very often they report once per several seconds each one. So it means that every second there comes like thousands of events, up to tens of thousands of events. But users rarely look at them, because the events are used for processing of data. They're not really used to provide any visual value for, or any visual information for the user. So there is other type of misbalance. So in this case, the transactional store needs to be faster, and then the read store can be a bit more relaxed in this sense. Or the transactional store should be fast in terms of that it just handles append. So it just adds information, very simple tables, or key value stores, or whatever else, append only, and then you put something on the side that will aggregate this information and represent it as a reporting model. So in my view, the idea of having two reporting models is very powerful, and that's where CQRS shines. I heard many people disagree. They say, okay, have one database, just use ORM, use SQL, and you're good. And this is CQRS, it's completely orthogonal with event sourcing. Well, okay, let's be careful about that. So you might wonder why we talk about Greg Young as the father of CQRS. Well, the need for CQRS actually came from the world of event sourcing. So when the initial versions of event sourcing as part of distributed domain design back in 2006 appeared, so apparently there was an issue that when you event source your system, you have events and you put them in an event store. So, and then something happens, and something happens like this, and it's even more serious than what I described with misbalance and disbalance and stuff like that. So you have your event store here. Right? So let me scroll a bit. And then you have your domain model, and it writes events in a pen-only fashion. So in here, for example, you have something that's called a booking, or yeah. And then you have lots of events over here. Well, not really a lot. Maybe the booking has life cycle of 5 to 10 events, sometimes just 2, booked, canceled, and stuff like that. But I have a lot of them. So you have 1, 2, 3, 4, and then potentially millions. And every of those bookings is stored in an event stream of 1 or potentially 200 of events. So imagine now you want to execute bookings like who is arriving tomorrow. Well, that's a pretty hardcore question to answer, because how do you know? You need to read all this stuff, reconstruct state of all these entities to understand your picture, basically what is the situation of booking, even if you look at a single hotel. You need to execute all these ones that we were looking at before to just reconstruct entities. You basically read the whole system just to find out where you are. So there is a possibility to again, keep the state of the entity always like in memory, and use it as a cache. And then when your system starts, you kind of rehydrate the whole system from that from events. But again, if you reach millions of events, it probably can take hours and sometimes days and sometimes weeks if it's a big system. So you never let the system down, but it's virtually impossible. So how do you execute queries in this picture? And this was the trigger for CQRS, in my view, to even sort of become a thing for Greg and the company. So they thought, okay, we cannot retrieve, we cannot execute queries on Event Store. It's just impossible. I mean, it's possible, but it's very hard. It requires significant amount of wiring and all different weird stuff. So what the proposal was relatively simple. So we'll just do it again. It again is splitting stuff. So here is your domain model, and it stores events to Event Store. And then, since Event Store, like our product Event Store, has the capability of handling subscriptions, you subscribe to event streams and asynchronously project them to what's called a reporting store, or read side of the CQRS. So because CQRS consists of command side and query side, sometimes referred as the right and left, sorry, right and read side, because people always say it's right or right, because read side is on the right and the right side is on the left, which is very confusing. So I prefer to call them command and query side. So you execute the commands over here. This is your transaction. But when you execute a query, so you have a question in mind, you go to reporting store and retrieve information. The funny thing is that it could be, the domain model can consist on many different types of aggregates, and they have their own streams, all of them. So, but when you subscribe, you can have multiple subscriptions, as many as you want, writing to the same sort of read model. So imagine you have a hotel aggregate, and you have a booking aggregate, and you have availability aggregate and stuff like that. And you have one or separate subscriptions, several subscriptions. And then you project them to a single document in MongoDB, or whatever document database it would be, that contains like a hotel info, availability, and maybe a list of bookings. So in this way, you completely separate your reading model from the stuff that happens transactionally, but it comes with a cost of eventual consistency. So you could imagine that when you execute a transaction, the operation is done. So the next transaction that comes will operate on the information that's already stored in the Event Store, because you will use events to reconstruct your aggregate. When it comes to reading, then it's up to your subscription. And if this subscription becomes slow, for example, then your data will be stale. I think that's one of the main sort of, if you exclude the technical complexity that involved in building read models, which exists, I cannot deny it. There is some wiring that needs to take place in order to implement all this. But here, when we talk about staleness of data, so I prefer not to call it like inconsistent, because it is consistent, but it's just behind. It could be behind it. It's always behind in several milliseconds if your subscriptions are fast, but it could be behind a couple of minutes. And again, I think we touched upon this during the question round on the previous webinar. This is all about the business. So as I gave example in the previous webinar during the question round, it could be a business like Amazon that, for example, doesn't care that much if they go out of stock, or they send something wrong to you, and then because they are so rich, they have so much money, they can say, okay, we give you a voucher for free because we don't have it in stock. We promised you, but we failed to deliver. So here we go, a better product and stuff like that. That happens all the time. For example, if you deal with hotels, they have certain degree of allowance of overbooking, especially if you talk about big chains, because they have a sister hotel nearby that can put you there and maybe give you a voucher or free dinner or whatever else. Airlines use overbooking all the time. So imagine that in airline business, it's never actually fully consistent. It is eventually consistent, but it is allowed because the business says we can tolerate certain stale data or certain degree of staleness in data because that's the nature of our business. It's fine to have overbooking. We can deal with this later. We have procedures in place. So when someone asks you about this, don't be afraid. Ask them what your SLA is. And sometimes if you talk about shipping containers over sea, the staleness of data could be like hours and sometimes days, so it's fine. So when you talk with the business for the first time, they might say immediate, but when they say immediate, everyone means a different thing. So okay, don't be really afraid to have still that eventual consistency, the eventual consistency, the sort of the risk that is there, it exists, but I think it's overrated. So there are techniques also how to keep the data that's presented to the user entirely consistent. So there are a bunch of things that you can do to mitigate this issue, but you need to be careful not to over-engineer your solution in terms of trying to meet the requirements that don't need to be met. So I want to show you a little bit about how it could be done in the code. So let me hide this despicable stuff. And I did a bit of refactoring, and I am, of course, showing you the wrong screen. So just a sec. Now it's the right one. I did a few changes in the application that we worked on before. So I separated in different projects. So the domain stuff is separated, has our beloved booking aggregate. And I call it aggregate now, just not to start typing stuff again. I separated the commands to a specific project because this is stuff we share. It goes to the outside world. It's our public API. And I have stuff in here. So the booking service now is doing the command stuff, and API just calls the booking service. So far we have implemented commands only, and all the commands are being sent to the application service to be handled. So it's very simple service. It looks what type of command it receives and then executes the operation. So for example, if you create a booking, it will just create a new aggregate. And if you execute a command on already existing aggregate, it just will execute this operation. I just hidden all this small wiring, loading the aggregates from the store, executing the operation, storing it back in the extension method. So what about queries? How can we do that? So I would say that we can use something that we used to call projections. I created a couple of things here, and I should use RavenDB for that. So just let me see if it runs. And the reason I'm using RavenDB, not because I'm a big fan of it, but because it has a nice user interface built into the database itself. So it runs. So how it works, we need several pieces in place. So first of all, I create an abstract class that is called RavenDB projection. And it implements an interface. Interface is very simple. It has one single method. It's called project. So basically, it doesn't do much. It's just a set of helpful methods to help me deal with the database. And I would probably be able to change it to use different type of persistence if I want to. So one more thing that I need in order to, so basically there are three things I need to do. First of all, I need my projection that will receive events and project them to my document read model. And I need something that's called checkpoint store. So why is that? Checkpoint store is the position in the event stream. We can say in the global stream of events, all of the events that we have. Because the read model can go down, the projection can go down at a certain moment of time. And when it spins up again, it needs to know where it starts projecting further on. So that's why we use checkpoint store, just to keep some sort of record on where we are at this particular moment of time, or after handling this event, where we are. So if I go down by deployment or by crash, or my server goes down, I spin up again, I read the checkpoint, and then I know where I am. And I have the implementation of checkpoint store, which is very simple. Well, it's not that simple because it has many lines that I can compress like this, so it looks a bit more compact. But it's all it does, and it does it because of RavenDB. I could use a patch API if I want to, so it doesn't need to load and store it again. So it can be done simpler. And with MongoDB, for example, you just execute an update. But basically, it does nothing more than loading the document and saving it back when I store the checkpoint, and just loading it when I read it. So, and checkpoint store, the projection, and the subscription. And then we need a subscription that allows us to subscribe to events in Event Store. And this is the particular thing that is pretty hardcore in terms of like what kind of infrastructure we need to have in order to maintain projections and read models. Because if you think about it, what you need to do is you need to subscribe to a stream of events that you're interested in. So for example, if you want to consolidate availability, bookings, and hotel information in one single read model, then you need to find a sort of a virtual stream that will consolidate all these events, because they're scattered around. So imagine that hotel number one has their own bookings, and it has their own stream for information for the hotel sort of master data, and it has their own availability. And then there are a lot of streams that represent data in across the system, but you want to have a single one that you can subscribe to and project all these events to a read model. Event Store has this very useful ability because, first of all, it has a stream that's called the all stream, and maybe I can even show it. Just let me log into the. I will show a screen in a second. I hope that's the right one. Almost. No. So where I am now. Okay, let me go here. No, I was in Firefox. So it has this thing that's called the all stream. AllStream contains a global sequence of events, all of the events that ever happened in the system. So, for example, if I go to the dashboard, over here, add an event, and let's say the stream ID would be hotel 123. And I add this. Okay, why is not valid JSON? I think it is. Bad string. Okay, maybe this. I've never done it before. Yeah. So then if I go to stream browser, I have a bunch of stuff going on here. So first of all, I have my stream that contains a single event, the hotel is registered. Then I have the all stream over here, and somewhere I get this event. So if I add one more, even if it goes to the hotel 235 or whatever, it will be here. We can see there are a bunch of events in AllStream that look strange. For example, all of these events they call system events, and I think we're going to remove them from AllStream in the future versions of Event Store. And but overall, the idea is that in AllStream you get all these events. So if you subscribe to AllStream, you're guaranteed to get all events from all streams in particular order, like when they executed. So you can use that to create projection that consolidate information from different sources, from different aggregates. You still do not invalidate your domain model because the main model remains the same. The domain model is important to execute commands. This is where your transactions happen, where your business happens. Queries are for informational purposes only. They are important, but they deviate from the main model significantly because they have different concerns. So how would we implement projection in code? So basically, if I'd say that I want to have a booking projection is a bad thing. So, but I have to do it. So bear with me. And it needs some sort of read model, which is basically a document, a representation of a document in document database. And I could say string. And let's say I'm not interested which hotel the customer stays, which is silly, but still, maybe for someone it's useful. And maybe that's enough. And in booking projection, I say I want to implement the abstract class of Raven booking read model.
Alexey, you still showing the web browser?
Oh, Jesus. Thank you, Matt. So that's all I've managed to do. And then supposedly that everything works, all wiring works. What I have to do here is that I have a session that comes to me, not as a I don't want to get dependency on the session because I want to keep it as a singleton. So I use a session factory to so it gives me the session. It all depends on the infrastructure. For example, MongoDB use iMongo database, for example, iMongo collection, which is singleton as well. So you don't need to have any factory, you just give it as a dependency. But here you can say, okay, I want to do the following. I want to use this, and the event could be, for example, booking. It's called book. Do I have this? Yeah, booking created. And I do something here. So basically, I need to populate the read model, and let's say update 1. And I'm sorry, I have to replace it by strings. I guess that's okay. All right, so no more GUIs here. And so I say created has this property, booking ID. And of course, I need a booking ID here as well. Or maybe I can create a read model that represents all the booking for customer, right? So that would be interesting. So let's rename it and say customer bookings and kill the read model. And maybe it's just a single document, but I will say I want to have a collection here, which is the list of booking, which is not the booking I'm looking for. I create a subclass here. And I will just instantiate it, so I don't get null reference or whatever else. Let's say I have a booking ID. And I have hotel. Now it makes sense, because before it didn't. So you see that I'm creating a read model that's not booking oriented, that's oriented by customers. So customer can log into the system and see their bookings on the screen, right? So it's just pretty useful. It's a valid use case. So, and we can have a status, paid or not. So let's add it also. In a simple fashion. So I have this, I hope this refers to the subclass. Yes, correct. So I say update 1, and this is my read model. So I would say I want to execute this operation. So read model dot bookings dot add new customer booking, and then I put some properties in there, which is basically what was that created, and so on. So I don't want to do all the properties there. Created dot and so on, and I can say paid no. Case create. Oh no, I don't need this. And I can say break, and then this. No? Oh, it needs to return a task. So what update 1 returns? Yeah. So the break, and if nothing happens, so if not that, so we'll return task. Complete task. So here is a rule. For example, here in application service, I have this switch expression that says I receive a command, I know how to handle it, and I do what I'm supposed to do. But if I receive a command that I cannot handle, I will throw an invalid operation exception, because I don't know what to do with it and been sent back to me. So apparently, I better tell the user that I can't do it, then just silently fail. In projection, the story is completely different. Projections, the rule of thumb is projections should never fail. So you want to move on with that. The only reason why projecting fails, basically, it cannot write to the infrastructure. The infrastructure is down. There you need to implement some sort of retriability, circuit breakers, whatever pattern applies to your situation, or overall is a good pattern to retry. Normally, you wouldn't allow the projection to move forward if the infrastructure is not available. So you stop right there because you can bring your read model or query model, reporting model, we can call it like this, to be inconsistent. And in that sense, it will be inconsistent because basically you skip some events. And then you don't know what happened. Where you are now, have you projected all the information, what is shown on the screen represents the truth. So it's better to have stale projection than invalid projection. So, but overall, if you don't know how to handle the event, you just ignore it. It's fine, because it might be not for you. Especially if you listen to Allstream, you get a bunch of stuff that you are not interested in, so you just ignore it. And of course, if you receive like something, events dot booking paid, you return update one, and you say, I want to have, again, this is wrong. I made a mistake. This is the customer ID, because our ID of the read model is not a booking, it's a customer ID. Paid customer. Aha. Here we come to an issue that sometimes events that are just good enough for the domain model itself do not convey enough information for us to produce a read model. So there are a bunch of ways to handle this. Sometimes you read from another read model, or sometimes you have a service that returns you the data that you need in the projection. And those ways introduce additional complexity. So you need to, for example, if you read from another read model, you can get into a situation then you read stale data, and that's not really good. So if you have the ability to populate your events with information that you might need in the projection, you better do it. And in this case, it's pretty safe to add one more property, because everything that worked before will work after the change, because it's what we call weak schema. So some properties that could be empty remain empty in the previous version of this event. And we add information that is relevant for the read model and say, okay, I want to add one more, which is a customer ID, because I need it for a read model. That's where read model can actually influence how you design your events. But generally, it introduces little change to the domain model, and this change is not really that important for the domain model, so it's pretty safe to do. So of course, I need to go here, not here, but over here when I produce this event and add stuff. And it will be, yeah, this. So right now, then we can go to the projection and say it's a customer ID, and I'll say read model. And it will be a little bit more complex. So first I need to do read model single, I guess. No, bookings, single. And single is not good, because then I have a chance that my projection will fail. So what I'm going to do is this. Apparently, there could be some bugs in your read model. For example, if I wouldn't find a booking, that means that I paid something that doesn't exist. So, but I would suggest not to throw and not to stop the projection in this particular case. And you'd rather move on and log this exception, inform someone to deal with this later. Because if you don't do it and you stop the projection, that all of your customers will be in a very bad situation that they do something, for example, they pay for their bookings and it's not reflected in their screens, which is probably not the best situation to be, because then they start to call you. But if something happens for the single customer, it's much easier to deal with a single customer there. Bookings, so let's say first the default. Booking ID. And let's say if booking is found, then I say booking dot paid equals true. All right, so this is a very simple read model, but it shows you that you go, you construct a document that doesn't represent what you have in a domain model. You create something new that is serving the reporting purposes only. So you don't have customer bookings aggregate. You don't have to, because all these bookings are handled by a set of booking aggregates. But if you want to construct this kind of model by reading your aggregates, you will get into a very complex situation. And by doing this simple class and putting in a document, you solve all these problems. I have this rule of thumb, right? We can call it heuristic, that in many cases, you might just want to start modeling your reporting model looking at specific use cases. You have a screen, you have a bunch of information shown on the screen, try to find out if you can easily create a new projection with a new read model that represents that single screen. But it's not always the case, because sometimes you have already this information produced by other projections that you already have before. So maybe it's easy for you to write a query that goes to existing projections and consolidate information. Sometimes it's easier to do it with relational databases, because if you go with document databases, that they won't be able to do the joins that you need. And then in this case, I would say, don't try to do joins in document database, create a new read model, a new projection that will do what you need to do. And you can create a nice degree of separation, because basically you need a new screen, you create new projection, you create new read model, and it can be done completely in isolation from the rest of the system, so you don't break anything. And you don't create dependencies on other projections, because they might have other people that are working on them. Because usually the reporting context, well, not usually, but sometimes reporting context is owned by the bigger group of people than just the team that works in that particular boundary context. So, because reporting context may become a context in its own, which I'd rather avoid, but this is how it is. So this is a very simple projection. And in order to wire it, we only need to do rather complex stuff, to be honest. So where is it? Yeah. This. It is not the best one, so I'm not proud of this code, but this is stuff that works. So I will copy it over. And this is about logging, so I'm not interested in that. So this is the stuff that can work and keep projections running and does all the wiring for you. So this is an extension. I think I do have it. I should have it. Event deserializer. It's over here. I'm not sure why it doesn't compile. Here, okay. And I don't want to do any logging there. So This is all it does. I will go step by step and explain what happens. So basically, when I construct this class, I will send it the event store connection, and I send it the instance of a checkpoint store, and I send it list of projections. So when it starts, it creates what we call catch-up subscription. And the catch-up subscription is, some people prefer, like Matt prefer to call it transit subscription. It doesn't create any trace on the server. So when you create a checkpoint, the catch-up subscription, it solely lives on the client, and it's your responsibility to handle the checkpoints. It's your responsibility to do whatever you want with that, but it has no trace on the server when you stop it. So when you stop it, it disappears. The only thing you see when you run it, when it actually executes in the runtime, that there is a connection to Event Store, and that's all you have. And you might even share the connection to the transactions and subscriptions at the same time, if you have it in one place. And basically, in order to subscribe to the stream you want, I use the method subscribe to all from. So imagine that I just started, but I used to work before. So I'm on events 1,035,000. I read this data from the checkpoint store, and I tell event store, okay, I want to subscribe to all stream from 1,034,000. And when events appears in the system, you call this function event appear. Again, the function is very simple. It receives a subscription that you can just use for informational purposes, for login or whatever else, but I'm not using it. And you get an event. So this method will be called for every event that comes to all stream, including the system events that you tend to ignore. That's what I do in this line. But again, in a new version, thanks, Matt, you will get something that will filter them out on the server so you don't load your network with that. The next step, you just deserialize it normally, and then you call all projections that you have, and you give them this event. So you call this method project, which we just implemented over here. So this is the one. And I can easily convert it to the switch expression. I will be like this. So, and it stores the checkpoints. It complains that this is a nullable thing, but it cannot be null. I know it, so I can do this wing, and it disappears. It's a new feature. I didn't know about it until a couple of days ago. So I know that's not null, and I'm pretty safe to store the new value. So for each document, I open some sort of transaction in RavenDB in this particular case. And well, I don't handle transaction here because I should have actually opened something like create a session and give it to all projections, but it's very infrastructure specific, so I didn't want to do it. In this particular case, there is a chance that my projections will be executed, they update the document, but then I somehow fail to store the checkpoint. It's not that bad. So you might think it's nasty, but it's not that bad. Because if I fail to store the checkpoint, the whole method will fail. And then if I have a proper error handling mechanism, I will try again. So what happens if I try again? Imagine that we came here, and let's say we were here, and the bookie got paid. So we project, and we update that was paid, and we set it to true, because this is the information we got from the event. Maybe it's even in the event. Yeah, paid status. And then this one failed. So we come here again, and we find the same booking and the same customer, and we again set it to paid. So you see that my projections are almost idempotent. And if you spot the problem here, you can buy yourself a beer or whatever you drink, because this guy is idempotent, because it doesn't do anything. It just finds it and sets it to paid, and if you run it twice, it will not produce any additional bad thing. But here, it is problematic, because if you just say, I created a booking and it failed somewhere else and didn't save checkpoint, or your service went down, and then you start again over here and try to project it again, but the read model was already updated, it would try to add a new booking to the list. But it shouldn't happen, because our list, ideally, it should be actually sort of not sorted list, but it needs to be to have a unique constraint. So what we could do is make it unimportant, because this is the best practice for projections. Projections need to be unimportant. So what we could do is say, okay, use the same, we can make a function because of dry, right? So we say create it, and if existing is not empty, then we'll just say return. So in this case, by doing that, we ensure that our projection code is idempotent. So of course you see me pointing over there, but it's right there. So idempotency is important because, again, not failing the projection under, well, failing under no circumstances is good. So avoid failing projections, make sure they're idempotent. Avoid calculations in projections. For example, if I would have some sort of running total over here, and I would say if the booking is created, and I say, okay, let me just add this field, and like double amount, and every time I create something, I would not only add a booking, but I also say amount. No, what I'm doing is created dot. Didn't I have the price? No, okay, imagine I have price. So what happens is that, again, I violated importance here, because maybe not in this case, because again, if I find it already, I won't do anything, but I might do it here, because here, for example, I always find it supposedly, because it should be there in the list. And if I do any kind of calculation, that it can end up adding the value twice because of the transient failure on the network, on the database. And this is something you want to avoid. So I'd say always prefer and try to avoid, always prefer to only handle values as they come in events. So if you need to calculate it something up front, then better do it there in the aggregate, and don't try to do it in the read model. You can still do it, because I personally cannot see any way how we can populate the total amount for that customer in event, because we don't know anything else than particular booking in the main model when we handle a command. But again, you might not even need it. You just say, when I query, then I just calculate a total based on information that exists in every booking. And then you don't need this value in the read model. So don't get overboard, try to put every value in the read model. If you can already calculate it from the value that are already there, for example, from a list of bookings, then you just don't need to put a calculated value in the document itself. So this is all it does, and I don't remember if I need to do anything else. Just a sec. I think I use it somehow in a hosted service. Yeah, I already have the service from before, right? So I will need to expand it. So remember, if people that joined from the previous webinar, you remember that this service hosts our connection. So it opens it when the application starts, it closes it down when the application stops. Then we could say, I want to have on my projection manager put in the constructor. And then when I connect, I need to do it async. And I also need to do await projection manager dot start. I could also stop projection manager over here. It's not required because all catch-up subscriptions will be automatically closed when the connection closes. It's just that if you feel safer, you can do it. To stop all your subscriptions, they will be eliminated and you won't receive any events. So this is all the wiring you need to do, basically, in order to implement read models. And essentially, you're already in CQRS world because your read model is completely detached from the write model. You write to event store, you read from document database, and you can start doing something interesting because, for example, I have a booking service. Let me call it differently now. I would say it's booking command service. And because that's basically the application's service as such, and it doesn't return anything, you can't even use it for handling queries. And I can create something different. I can either rename this to command API, or I can again split the API too. So I can call it booking command API, and I can create something that's called, for example, booking query service. And it won't have any kind of, it doesn't need to have any interface. And I can say all I need is func of, and I will, yes, it's better to do it this way. What's going on? Func, yeah, like that, and I have a constructor for it. So, and if someone calls, sort of, it won't be HTTP post. I guess you need also some sort of API contracts. I can put it here as well. So I say, okay, this is the booking queries. And then I could say I want to have class get customer bookings. And I can create a class that's called result. And it will be very similar to the one that I have here. Something like that. So when I do the query, I would say I want to have sort of task of list of, no, not list. It's not, the result is wrong. Basically, the result needs to have the, like some letters, public list, or maybe booking. No, wait a sec. I don't want to return a number, but I can also do that. It's just okay, fine. List, maybe array, or I collection of, what's it called? Looking queries dot get customer bookings dot result. Yeah, and get, and I would accept from body. I'll just say, because I use, it's dedicated for that, so it will use only booking queries. So I can import static members, and I say get customer bookings dot no query. So this is it. So I would say I want to open the session. Now using. And then I can query it. So I say return session dot load query. This is query async. No, it's already async query. Async method because it's async document session. So I would read models. Do I have it? No. Customer bookings. I don't remember how to write rating queries, but to get the idea, basically, I'm going to query. I don't need to query anything. Basically, I just need to load it because it's by ID. So what I need to do is just query dot customer ID, and then I need to transform it. So, and then I do some kind of transformation. Return result dot. Of course, I need to wait it. Dot select bookings dot select. It's called get customer bookings result. And then I do this. And I say to array, for example. So I don't want to return enumerable because it doesn't make much of a sense in a async call. And here I go, I have a query service, and then I can easily put it in the API and just say, okay, I want to get my, oh, I actually have from body, which is wrong. It should not be in the application service anyway. So just about bookings. I can of course introduce the parameter not in the query itself, but use from URL segment to some of that, and I can just do that as well. And let's say, and imagine that I have a booking service. And then I just call it, right? Wait, I just need to remove async. But it might sound as an overkill because, for example, if you have a query service, if you just say, I want to have a query API, and it will be a controller. Because now it takes two dependencies and only one of them is used at a time. So it doesn't look right. And you could say, I don't want this. Oh, I didn't need to use the controller. It was working before, right? And I just remove it, put it here, and instantiate it from the constructor, initialize it, and just remove this one. And I move that method. So do you really need a query service to do all this work? Basically, not always at least. What you could do, you can just create a bunch of extension methods for your Raven session or whatever else and use that directly. Or you can just query your database from the API. It doesn't feel right because if you're going to implement this query API using messaging or using whatever else, something different than the web API controller, then you will need to rewrite a lot of things if you just execute a query to the database from here, but you can also isolate it. Like, okay, I create extension method for my database. Like I just say, instead of doing the query service, I can say, okay, this is what I'm going to do. Static booking queries. And now it's just copy this method from here. And then it will just be a set of functions that you execute on a particular instance of this. So I say it will be this get func. You can also create name delegate if you want to. And it needs to be static. And just something like this. And then you don't need any, you don't need query service as such. What you need to do is basically have func. And you, instead of using that, you would just say get session, get query, and I think it just imported something incorrectly because that my class is called the same. And now let's just do that. And then you have a decent degree of isolation because still all the queries, you can just rewrite them, but the API might even not change that much. Because imagine instead of async documentation for Raven, I use iMongo collection, for example, iMongo document collection. But I would just do the same. I would just say get and pass the same parameter. And then because I have a new set of extensions, my query will still execute. And the only thing I would need to change is these 2 lines of code in that API. So it's up to you. If you use query service in many different APIs, you might put it in the separate class. Again, testing wise, it doesn't really matter because if you want to test your read models, I suggest you do it with a real instructor. So spin up the container with your database and really at least write the document that was there before, execute a projection and read the document back and see if it was projected. You don't really need to go through Event Store. This thing can be tested, but this is a sort of repetitive test. It only tests if you have registered everything correctly in your service, or it can test if your projection manager picks up your projection or not. But overall, the projection testing is very easy in terms of just create the before document, project an event using this very simple method. You just call this one, project, and what you want to project, and then read the new version of the document and see if it matches your expectations. That's all it needs to do. So testing projections is also not that hard. So yeah, we are way over time. So I can clean it up a bit, make it work, put it in a repo, and if you subscribe to our mailing list, we will send you the information where to put, where to find stuff. And again, if you have any questions, approach me on Twitter and stuff like that. So now I hope that Matt was moderating questions. So let me just switch to that and let's see what we have. Matt, you there?
Yeah, I've been answering questions like crazy. So there's about 10 at the moment that I thought would be useful to answer in a little bit more descriptive manner. So they should be in your Q&A section now.
All right.
To read them.
Yeah, just go one by one.
Some of them quite long.
Okay. Do you want me to read them or you?
I'll let you read them because I'm just answering a few more at the moment.
Okay, good. So how data will be replicated to Elasticsearch in order to be fetched when executing the query? So if you use event sourcing, that's pretty straightforward because you are not limited to create one projection. I need to mention this is, I personally consider this an anti-pattern. I've seen many times and I've done this myself. So I have a booking aggregate over here. Where is it? Here. And the first thing I did, subscribe to what we call event store category stream. So basically I can show it in the user interface, just a sec. Maybe I shouldn't because it leads you towards another pattern, but I will still do it. Yeah. So this one, that's event type. No. It was 1, 1, 2, 3, and basically I can go here and say C hot. And then you get all events for all hotels. So you see it at hotel dash. Event store will use the dash as a separator and put all events for all streams that start with hotel in this stream. And that's what I used. And I saw many people using and doing the same mistake. Basically, replicate the state of aggregate in the read model. It has a valid use case sometimes. So for example, you want to have a very fast cache representation of aggregate so you can make decisions easier. So sometimes it makes sense, but most of the time it doesn't, because the essence of read model to separate two models. So basically you have a reporting model addressing reporting needs. If you do stuff like that, represent your aggregate in the read model, you don't go outside of your model. You're basically replicating the same model in a different store, which is basically defeats the purpose. Sorry for repeating the word, the parasite word. You're repeating a model in a different store, which is stale in that regard. So it's not useful that much. So please consider not doing that. Why I started this? Because when you have a read model, you're not limited to create only one. Per aggregate, for example, or whatever, you can create as many aggregates per as many use cases, or sorry, you can create as many projections and read models as you have use cases that are valid. In this particular case, the question is about Elasticsearch. Nothing stops you to create a new projection that will just project all of this to Elasticsearch. Just go here, replace all async document session to Elastic whatever Nest client, and then you have it. The only problem that in particular Elastic is a hard beast because you might end up writing some painless scripts. Painless is not painless, it's their language name, to update complex read models, and you don't really want that. Then you might end up like producing documents in MongoDB first and use the change stream to put it in Elastic, which is in a sort also a projection, right? So you listen to change stream of one database and project them to another database. So projections are not only related to event sourcing. It's not really the pattern that is exclusive to event sourcing. Projections find their place in different scenarios. For example, Cosmos DB has unlimited change stream. It's pretty easy to produce project from Cosmos DB from one model to another. Is that the only issue there is that Cosmos DB would say, okay, I have a bunch of changes, and I don't know how it implements there, but I know that in MongoDB, you get a stream of updates on that particular document, and you have a document, and go figure what happened. So you need to actually look at particular things, unless you project to exactly the same model like you can do with Elastic. Just get a document, put it to Elastic, overwrite the previous one. But if you need to do some manipulation, then you sometimes need to find out what exactly has changed. And then you need to compare the versions of the document, what you have, and what is new, and then put some updates over there, which can be complicated. This is why I see, and I've done it before myself, sort of projection from one database to another, as soon as database has the feature of real-time change stream. But the usage of that case is very limited. It's usually when you just, for example, in my practice, we had a case when we needed to project to Elastic, but updates to Elastic were really hard to do because we ended up having Nest scripts and stuff, Nest calls with their API is not the best in the world. and even writing some painless scripts. And that's not what we want to do. And one smart guy came to us and say, why don't you project to Mongo and then from Mongo project to Elastic? And that solved all our problems. But this is a very edgy case. So again, write an Elastic projection, and this is how it gets to Elastic. There is no magic in that. It's pretty straightforward to do. So, and let's take the next one. Oh, it's already gone. No, okay, the next one. Here. I've heard many times people say you should only use event sourcing if you absolutely have to. Has it changed recent years? What if you become professional in implementing and maintaining it? What is your take on this? I think it's like anything else. Like some might say you need to take a car if you absolutely must to. If you ignore environmental impacts and if you have a car that doesn't consume any petrol, doesn't emit anything, it's just a matter of practice. So again, handling a car is a tricky business when you start doing that. You need to remember a lot of rules. You need to try not to kill anyone and not even, you know, create or produce any damage, would it be physical or moral? But at the end, you make it like you automate it, your skills become higher and you do it like on a daily basis and you even enjoy that. That might happen with application of any particular pattern or any pattern. So I would say that absolutely have to. I would say if you find it useful, then why not use event sourcing? At least try to use event sourcing. As I said in the previous webinar and question round, event sourcing becomes tricky when you accumulate certain degree of history and then your domain is heavily changing all the time. And sometimes in the startup phase, for example, you have a lot of pivoting. So you move from one business case to another and you don't even know what you're doing. Sometimes in that case, it becomes a burden to maintain the system. There are, of course, patterns to avoid this, but it's still a lot of wiring that needs to take place when you do stuff like that. If your system evolves, so you know what you're doing, and you know the business case, and you have proper people that you can talk to in terms of the business and the domain, and you just evolve, then it's actually easier sometimes to deal with event source system. Because, for example, they say, you know, a very common thing, I need a new report. So, okay, it will carry a SQL database because we need to create 25 new indices and yeah, stuff like that. So in the event source system, you say, okay, never mind, I will create a new projection. I won't touch anything in the existing system whatsoever. I will create a projection, create a new read model, and off you go. So sometimes it's easier, but it's a matter of practice. If you're just starting, I would say start somewhere that you can have some sort of playground. At the same time, there is a risk of start with very simple application that you don't see the benefit. So maintain the balance. So try to do something interesting. Maybe try to implement some sort of something that requires synchronization, because synchronization with events, as I said before, eliminates the impedance mismatch and it eliminates the two-phase commits that you usually have when you, for example, write to the database and emit the main event for integration purposes. So this stuff goes away. So there are very useful patterns to deal with legacy systems, for example, are building an event source system on the side. We can probably have a webinar about that in particular. So there are cases that you might just play around with that. Don't bet on it if you're just starting, because you might end up in a very bad position and writing new blog posts on Medium saying event sourcing is crap. Apparently, I don't want that. That's not our purpose. But you can write something important, reasonably small, directly benefiting from event sourcing, in particular the ability to create multiplicity of read models that are specific to the business case. And then you will see the value. And then as soon as you see the value, as soon as you gain more practice, you can expand sort of the scope of application. So some people say, I couldn't imagine building any other way, so I want to build everything event source. I would say keep the balance right. So, but if there is a business case which is reasonably complex and have time aspect in that. So you have a sequence of things happening, business process, life cycle of entities. Like it's not just the master data. Like for example, I would not put the hotel information in event source system because there is no need for it. You just have something that changes really rarely or never at all. So why event source it? Put it in a document and call it a day, and then that's it. So yeah, for that task, it would be definitely an overkill. So if a domain model is just not suitable for an event sourcing approach, how better to use other persistent systems and then append the events for reporting in the same request? Well, I've never seen systems that are not applicable for event sourcing, but I'd say you can use different techniques like a described change stream of the existing persistence. So for example, MongoDB has change stream. The only disadvantage is limited in size and in time, so you might lose some data if your projection is down. SQL Server newest version has change stream. Cosmos DB has change stream. Amazon what's called DynamoDB has a change stream with kinesis and stuff like that. They actually advertise using projections. They don't call it projection though, this way. So you can do it differently. With events, it's trickier because if you have, you will end up with two-phase commits. So you have a risk of losing an event if your messaging structure is down or event store is down, for example, or you have transit network failure. So imagine that you update your write model and you didn't update your read model, then the read model becomes not stale, but inconsistent. There are also techniques to avoid that. Write your events in the same transaction to the same database, and then pick it up and publish it to whatever you want to publish. So it's perfectly fine. So you can still do it. And it might open the door to event sourcing for you later on. So if you analyze your domain and find that's actually not that bad. So, but again, I'd like to see the domain that's not suitable for event sourcing, but it would be an interesting case to talk about. Do you recommend using event sourcing without domain model? I don't do that, but I know that people do. So event sourcing, well, basically the answer is no. It's just that the definition of domain model can deviate in people's mind. So what I could say that events, in my view, is the first technique that allowed us to say the behavior, because when we talk about domain modeling and such, we want to catch what people do, not just nouns and create a dictionary of things like this called the hotel, this called book, and this called availability. But things that people do, the nouns, book, pay, partially pay, cancel, and all that has particular value because we want to know what was going on so we can analyze it and produce better result and better customer experience. So if you're not intent, if you don't have a domain model, because we call a rich domain model is a set of some code, because domain model is always code, right? That represents the behavior as well. It's not an anemic domain model. Anemic domain model is just a bunch of classes that contain properties. So if you have a rich domain model, then you have behavior, and you want to capture this behavior, and you capture this with events. So if you don't capture the behavior, why do you need event sourcing at all? Or so if you end up with having events like property changed, and then you send property names and values as a metadata, that's not event sourcing. We call it property sourcing event pattern or anti-pattern. I would strongly advise not doing that because it's just, it defeats the purpose. It introduces complexity without getting any benefit. So in order to project the partition stream by customer ID, customer ID need to be added to each event. Yes, I agree. That is a fair statement. That's what I mentioned when I was writing the code. So sometimes the projection require you to put more data into events. It's not bad. So Matthias Verais wrote a series of articles about messaging patterns related to DDD, and he calls this FAT events. So sometimes you need more information in events. So there is always a balance between thin events and fat events. Thin events tend to be very concise and only deliver information that's needed for the domain model itself to facilitate the transaction flow. But
Alexey, we've just lost sound. Sounded like a cable pulled out. Still nothing, by the way. Still nothing.
sound?
We have sound.
Now there should be sound. Yeah, I see the microphone is.
Yeah, it's working.
Yeah, so, okay, good. All right, the reason is that my wireless mic just died because it ran out of battery. So luckily I have another one and we continue. So I'm not sure where it actually died. Was it the customer ID?
Yeah, that was one you were talking about.
So this is a fair statement. That was my thing. So FAT events sometimes are useful. I mentioned Matthias Verais writing about messaging patterns in overall and relate to DDD. It's a balance between thin events that are very concise, addressing the particular thing that needs to be handled by the domain model and nothing more. But sometimes it's valuable to put more information to events, and we call it FAT events that convey more information than they intend to, just for the sake of giving information to others. For example, you might produce integration events. You might need to have this information in your read models. And so adding information to events later on as well, that doesn't really convey domain models required information. So for example, the customer ID in that event was not required by the domain model, but it was required solely by projection. So I can add it later. Of course, you will lose the information that was there before. So all the historical event won't have this customer ID if my system, for example, was live for a year. So I would say I'd either migrate events, or I would create a workaround in my projection that it will query another document to fetch the missing information. But as soon as it catches up and say, okay, we move on with the progress of the life cycle of the system, the more events will get this information and the need for a hack or the workaround will disappear. So this is how it is. So this is a fair statement. What extension you use for your IDE? operators. Well, it's rider, so I don't use any extensions, to be honest. I just use rider and material theme. So it's how it is. It's not VS Code. I'm even wearing the rider t-shirt today, just so you don't get confused with Visual Studio Code. All right then. And regarding the point avoid calculation projection, say I have a book aggregate and copies of the book are added with copied added event. An event contains only the number copied added. I would see the total number of copies in projection. Where does this happen? Do I need to introduce additional fields and copies added and introduce new events, copies changed? I'd say when you add copies, your aggregate probably handles the stock. I would say that's not a book. It's like book stock or something like that in a particular warehouse, or maybe across different warehouses, and say, okay, on that warehouse I got 1,000 more copies, so I have stock. So in that regard, the aggregate contains the actual amount of items that you have in stock, and the aggregate has this information. So nothing stops you from adding this new total to the event. So like before, adding new stuff to even already existing events, so not breaking the contract by using Vix schema, like put stuff there, and then you have it. So of course, you never know what you would need up front. So I'd say when you do the initial round, you probably develop projections on the go and you know what you need to put there. And that gives you a good indication what kind of scope of the what information you will convey in events in order to satisfy all the needs. If the demand comes later, I wrote some examples in the book that query the model that has it. It's if it's a projection group that is hosted in the same place and it uses the same checkpoint, it's pretty safe, because then you have very high level of guarantee that the stock level in another or whatever figure you need is already present in another projection. So, but if you absolutely must do the calculation, then you need to ensure idempotency in different way. For example, keep the version of the aggregate inside the read model, and then ensure that you do not project the same event twice by using the version, because every event is versioned, right? So you know what was going on, especially if it goes to particular aggregate. Because in this case, when I do customer bookings, I don't have the version, because every booking has its own version cycle. So I have no clue, but I can put a version in each individual record of the booking. And then I probably can solve this problem too. So there is a way to do that still, to do the calculation and don't mess with that importance. So event version is, or aggregate version as such, is one of the ways to do that. So I guess there were all answers or all questions that are online that were not answered by Matt. This is very much less than we had before. Thank you, Matt, for helping with that. So I see the message from Adam. Hi, Adam. How can event modeling help design events or systems? I think event modeling, from what I know about event modeling, event modeling concentrates on basically putting stuff into the timeline, telling the stories in a single particular flow, because the flow of every transaction can deviate. For example, if we execute a command, book the hotel, and apparently we find out that the hotel is not available, we need to do something else. And then we have a different flow. So it's not exactly the design level event storming. So I think it puts more stuff on the board. And in particular, what I like about event modeling is putting user aspect on that and what the user sees. So the screens are in there in the swim lanes that represent different parts of the system. And then I see a lot of value by looking at screens, to be honest. So sometimes we go from the business case. Let's say we have a transactional flow. We have command execution that produces events, and it go further on, and then they can produce new commands. There will be reactions onto those commands. There could be some integrations, interference of external systems and stuff. And then you have a full wall of sticky notes, and it's really sometimes hard to digest the whole thing. So when you tell the story in a single particular use case that represents only like the happy path, the failure path number 1, the failure path number 2, then it's much easier to digest. So you have the sort of full thing in front of you. And I like this, like I said, like looking at screens because it tells me a lot about the customer needs. Because sometimes when we look at systems, looking at requirements on these thick documents, it's really hard to understand what kind of problem the customer is facing. And when you look at the screens and you talk to the customer and you know what they want, you sometimes see that that's not addressing their need. Because I heard many times that, okay, customer wants to know about who took the rental car and left the country and it's not legal. So they want, the business analysts say they want to report who left the country to yesterday. I'm saying that's not solving the customer problem, because they need to know now. They need to call the police and say, stop them at the border because they still like somewhere close. And they don't need the report. They need something else. And by looking at the screen, I understand what they might need, and I understand a better way of representing this information. And I see the read model very clearly. All the screens, the wireframes, basically for me represent read models, and I can get a lot of insights by looking at them. And I can understand if I have enough information to read model to execute my next command. So the user knows what they're doing, what do I need to put in my domain model, and stuff like that. So there is a lot of value from going from UX and UI side of view, at least UX, to understand the flow and the problem and design better solutions. So that's all we want, right? So we want to have systems that actually solve someone else's problem, not just playing around with code. Sometimes we do, but that's not what pays the bill. So, all right. I think that was all. Thank you very much for coming. And it's been more than 2 hours. I think we're all tired. It's quite late for me. For some it's morning, for some it's middle of the day. So I wish you all good weekends. In many countries it's a long weekend. And I'll see you next time. So our plan is to host next session and go deeper to read models. Basically, I covered quite a lot during today's session, especially answering questions. But I want to write a bit more code and show different types of read models on a bit more, a bit richer domain model. So I will prepare some stuff in the solution, and maybe also go to some sort of like projectionless microservice stuff, and create a read model on the side, and do better databases and stuff like that. Maybe even do Elastic, I don't know, if we have time. So deep dive to read models next time. And thank you all for coming. So yes, Matt is writing. If there are any more questions, reach out on Twitter. So do the same for me. You can easily find me. Just Google me, and it's only one, I guess, that will come on the top. So thank you all again. And yeah, remember to give us feedback. I know that this was not without glitches, and I need to improve my writing and maybe not do the writing live anyway. So just be honest, and see you next time. Thank you very much.